All right, guys, here's your helpful DeltaMath 1.5 limit properties video. So if you are struggling with understanding how to work through some of these problems and or just want some help on them, go ahead and watch this video. So I'm going to click on limit properties graphically. And it says, given the following graphs of f of x and g of x, find the value of the limit of f of g of x as x approaches -1 in the simplest form, okay? And so what I'm first going to do is identify the fact that this is a limit of a composition of functions. So if I scoot on over here real quick, technically I start off with this, right? Limit of f of g of x as x approaches -1, but our limit properties tell us that really what I can be looking at is f of the limit of g of x as x approaches -1, as long as this limit exists. And so what I'm actually going to do is go back to my graphs, and I'm first going to find the limit of my graph of g of x as x approaches -1, and then I'll plug it in here. So if I go back, go to my graph of g, and as I approach -1, it looks like my limit as I approach -1 of g of x is 1. So then I'm really just finding f of 1. And then if I'm finding f of 1, I use the second graph, because this is the graph of f, and I actually find the point at 1, which would be -2. So I type that in here. And there we go. And then they work through the whole process the same way that I just kind of did, right? So they rewrite it using the composition property, and then they figure out the limit of g of x, and then they find the actual point at 1, okay? Let's do another problem. All right, so it's going to be a similar format, but this time we're just approaching 1. So let me go back and clear off my whiteboard a little bit. And this isn't going to be, it's just going to be 1 now, I think, right? Yeah. So it's still the same setup. So this time I'll just be approaching 1. So the limit of f of g of x as x approaches 1 is really the same as f of that limit. So I'm going to find the limit now of g of x as x approaches 1. So use my graph of g. And as I approach 1 from the left and the right hand side, my limit is 1. So then really I'm just finding f of 1. And then I actually go and I do the same thing. F of 1. There you go. Weird, my answer is the same both times. I don't know about that. All right. All right, let's see if we can find one where oh, there we go. We got x approaching -8 now. So we'll see what that will bring to us. But it's still f of g of x. And so I'll start off by tweaking my work that I was doing. So it's still f of g of x, but now I'll just be approaching -8. And so again, my limit properties say that I can just take f of that limit. So I'm going to first find the limit of g of x as x approaches -8. So use my graph of g, go over to -8. My limit looks like it's going to be 2. Remember, you're looking for the limit, not the actual point. So 2 would be my limit. So then really I'm finding f of 2. And then I use my second graph. And if I find f of 2, it gives me +2. Voila. And then I don't know, oh, here we go. I wanted to get to a different problem. So this one has more the same properties of limits, focus, but this time instead of doing composition of functions, it's got multiplication of functions. So let's go ahead and we're going to work through this one instead. So limit as x approaches -7 of f of x and g of x being multiplied. So this one, as we approach, what was it, -7? No, yep. And then in this time, instead of doing composition of functions, it's f of x times g of x. And so our properties of limits say that if what I can do instead is I can find the limit of f of x as x approaches -7. And then I'm going to multiply that, whatever I get for that number, by the limit of g of x as x approaches -7. All right, and so I'm just going to find the limit separately and then multiply them together as long as they both exist. So we just have to find them from both graphs. All right, so here's my f graph, and my limit as I approach -7 is -4. And then I'm going to multiply that by the limit as I approach -7 of my graph of g. Uh-oh, my limit here that I look at -7, it does not exist. And you can't multiply -4 by does not exist. So we're just going to say our general limit, or excuse me, our final limit does not exist. Boop. There we go. And again, it works through the whole thing for you. All right, so there might be some other ones that might include like addition, subtraction, division, and then again, composition. Composition is the hardest one, I think, so that's why I wanted to do a couple of those. But if you have any more questions on 1.5, the DeltaMath assignment, let me know.